Hello everyone. So today in this presentation, I'm going to explain you all guys yet another topic from my data science assignment. So the topic for the video is model evaluations and the role of cross validations. And what's the purpose of the data set here? So in machine learning, we divide the initial data set into distinct non-overlapping subsets to simulate real-world conditions and ensure the model generalizes well to new data. So there are some key factors that you have to have a look on. The training set has a purpose to build the model, the teacher here. So and the key action that it performs is this is the largest portion of the data. For example, it's around 60 to 80%. The algorithm learns the underlying patterns and the relationship from this data. Now comes the now comes the validation set. So its purpose is to tune the model. It's the coach here. What the key actions validation set perform? This set is used during development of fine-tuned hyperparameters like setting the control how the model learns and make decisions like when to stop training or which feature to keep. It prevents overfitting to the training data. Now comes the turn for test set. So its purpose is to evaluate the final performance, the final exam here. So it performs, this is the final unseen data used only once to provide an unbiased estimate of the model's accuracy, scalability, and overall generation error. The critical role of the test set is that the test set must remain completely separate throughout the entire model development process, like training, tuning, and selection. If the model sees the rest data before the final evaluation, the accuracy matrices will be optimistic, like estimated, as the model has essentially cheated on its final exam. The simple train validation set split. This is the most straightforward way to divide data, typically done when the dataset is very large and static. Simple split methods are the entire dataset is divided into three parts here: training, validation set, and test. Sorry. Training set is for around 60%. Validation took 20%, and the test as well took 20% here. The model is trained on the training set and tuned into the validation set. Once the model is finalized, it's run once against the test set for final performance reports. The drawback of a simple split: the primary limitation is that the result can be highly dependent on the specific subset chosen for the training and validation set. If the initial random split separates a rare but important pattern into the validation set, the training performance might suffer significantly. The resulting accuracy estimate has high variance because it relies on a single sampling event. Cross validation, the robust solution. Cross validation, like specifically K fold cross validation, is a more robust method for model evaluation and selection, designed to maximize the use of limited data and provide a more reliable performance estimate. Now, what is this cross validation? In K fold cross validation, where K is typically 5 or 10, the entire data set, excluding the final test set, is randomly partitioned into k equal sized mutually exclusive subsets or folds. The model training and validation process is repeated k times. In each of the k iteration, a different fold is reserved for validation, and the remaining k minus 1 folds are used for training here. The final estimated performance is the average of the K accuracy scores. How cross validation differs from a simple split. So as a feature, data uses so data uses the validation set. So the in feature data usage, the validation set is fixed and used only once for tuning. K-fold cross validation may what happen with the data usage is that the every data point is used for validation exactly once and used for training k minus 1 times. When performance estimates comes, the validation splits comes to the single high variance accuracy score, where the k-fold cross validation does an average of k accuracy scores, low variance and more reliable. Risk of bias, bias with simple train that high risk that the validation data is not representative of the whole dataset, and the low risk of bias because the process test the model across multiple partitions of the data. Typical use case may what happened with the simple training and validation split is that it becomes fast evaluation when the data set is extremely larger, and the standard practice for model selection comparing two models and when the data set is small or moderately sized. And the thing which I want to say in last is this thing that always emphasize that the core purpose of cross validation is to obtain a low variance, reliable estimate of the model's performance by systematically testing it on multiple partitions of the variable of the available data. It's the gold standard for comparing two competing machine learning models. So yeah, that's it from my side. Thank you for watching my video.